And welcome everybody to the Smash News Network, least busted name in news. I'm your host, Dan, aka smAsho, and we've decided to do a YouTube live stream here. I know we've been slacking in our YouTube live stream duties over the past month or so. So we're back, and we're going to play some fresh tracks from Golden Cat Productions. We'll be back in about 2 minutes to talk about things like geomagnetic storms and earthly storms. So tell your friends and foes that we're streaming, and we'll be back with you in just a moment. This track is called Tilt-A-Whirl. We're going to leave it at this low volume here while we get ready for our live stream. All right, so check it out. We're doing a YouTube live stream here for once. And we've been slacking on our YouTube live streaming. Not necessarily requirements. Certainly not requirements, period. As the channel is free to do what it wants. As far as paid endorsements and so on, we ain't got no such thing. So, great solar prominence going on here. Let's scroll up a little bit here. Fantastic imagery there from the NASA GOES 16 SUVI. And certainly some of that coronal plasma is expected to be out into the greater solar system. That's the part in which you live. So let's put your comments up on the screen if there are any. And there's only one from me at the moment. So anyway, let your friends and foes know that we're streaming live, and thanks everybody who's tuned in. You may or may not realize that we have limited access to how many people are actually viewing the video. So anyway, we've got great solar prominence imagery for you there, and also some great imagery of what's going on planet Earth. And we've, oh my God, it's a technical difficulties. Now, here at the Smash News Network, we try to respond to such things with poise. Have pause if you see a pause in your poise. So what we're looking at here is the visible satellite. And we've got tornado watches over a portion of the U.S. And let's actually switch to a different view here. We're going to go to the shortwave radiation map. So just to give us a little better insight into what's going on here, let's take a look at this convergence zone. It's quite significant. And hopefully it's not causing too much damage. So we've got a huge convergence of warm and cold air here. Warm, moist air plus cold air equals fireworks. And if you watch our meteorology segments, you may realize that there are indeed some issues happening over places like Tennessee and Kentucky, as we've got some pretty violent systems out there as Earth's atmosphere attempts to reach static equilibrium. So we're going to actually bring up the visible here once again. We'll just go to a shorter period of time. And we got to have a less zoom. So let's try that out. We've got ice storms happening in other portions of the country also. So interesting stuff going on. Also, last I checked, geomagnetic storm conditions and a coronal mass ejection and a huge prominence happening while we stream live. So it may be a little bit of an unexpected live stream for most of you viewers out there, as we haven't been doing very many YouTube live stream views. But hey, when the conditions are right, why not do some stuff? So, all right. Let's take a look at some additional information here. Let's look at the Auroral 30-minute forecast. It looks like we've come out of geomagnetic storm conditions. And we'll just put up the Aurora Forecast here. Just give that a minute to load. So we did see a brief geomagnetic storm there. As we forecasted, it looks like it's probably subsided. And you should see the likelihood of Aurora there dropping down at the end of that clip. And of course, you never know when these things will make it into the real news, into the sort of the mainstream news, right? Most people really have no clue what's going on as far as atmospheric physics and space weather and so forth. So we like to open the doorway, if you will. So shout out to our viewers from places like Alberta. Probably saw some aurora. You may have been asleep at the time. Now at the Smash News Network, we just simply don't fall asleep. What we do is we play an additional track here and take a slight break. So we'll be back in about 2 minutes. Here's a track. This is called When I. It's available on this stream exclusively. All right, and we're back. So yeah, we're going to look at this in a little bit more detail here. Let's take a look at some fascinating weather data. So just give me a moment to bring that up, folks. I apologize for the delay. We're going to show the water vapor map here as there is a massive convergence happening. We can sort of show you what's going on in the atmosphere. You've got some cold air contacting some warm, moist air. And that is why places like Oklahoma and Kansas, of course, as featured in The Wizard of Oz, feature so many tornadoes. It all has to do with cold air making its way deep into the southern U.S. So this time we've got moisture coming from Texas and headed up to the northeast. And there's some cold air trailing it back here in places like northeastern Colorado. Let's take a look at this convergence zone here over Kentucky and Tennessee. Just give that a minute to load. We are streaming live. There we go. So just realize, folks, that in these areas, the atmosphere is trying to reach static equilibrium. And when you have a massive high pressure zone like this, pushing in behind all of this low pressure area over here especially, it's a very low pressure area that is sucking that more massive air toward it. Remember, folks, a lot of the wind which is blowing is actually a result of suckage. Yes, suckage. It's not just censorship. It's also one of the atmospheric inputs. So let's bring up the visible again. This time we're going to actually go to the full disk imagery because, well, it's just going to look awesome. So let's put it up. Put your chats up. If you've got any sort of meteorological requests, let us know in the comments. We will consider it. Wow. Does it really zoom in that far? That is a serious zoom. See if we can get the Kentucky, West Virginia border area. We're going to reduce the number of frames. That looks about right. Some missing data in there just to make it as unsmooth as possible. So you can see some variations there in cloud height as the sun rises. There's a timestamp. And thanks for tuning in. I see 6 viewers. Let us know in the comments who you are and what you want. Are you lurking? Stop lurking and leave a comment. We'll put it on the screen, especially if it's poignant. Anyway, that's what's going on in the visible satellite. And by the way, if you head to weather.gov, you will note that we've got some, looks like they've been reduced here to severe thunderstorm. Just oh no, tornado watches in that whole area there. I'm going to try clicking on this rare occasion. There you go, Mayfield, Flash flood warning there in Mayfield, south of Paducah. Let's move this view a little bit to the west. And you can sort of see the zone here where the cold air is causing a sudden equalization of the atmosphere. And of course, you get a lot more detail on the visible satellite than you do with the shortwave radiation map. Let's try the shortwave radiation map once again for that local region. We can put up the full 50 frames here because it doesn't rely on visible light. Anyway, there's what's going on. Let's take a look here at some additional space weather stuff. We looked at the 30-minute Aurora forecast. Let's see what else is going on. First of all, was there a solar flare? Well, you can take a look at the GOES X-ray flux right there. If there was, it wasn't a major one. Only in the B-class range there. And let's take a look at the planetary K index. Are we out of geomagnetic storm conditions? Now back to a KP of 3. So back to geomagnetic calm conditions as we forecasted in our daily space weather videos. Make sure you check out the youtube.com/smAshomash/videos for our most recent. We've been putting out 3 daily space weather videos per day, hence the term daily, because we wanted to compartmentalize the different sections. So let's take a look at the real-time solar wind here to see exactly what's changed. What we noted was that the BZ moved out of negative territory. And there's your real-time solar wind from the Discover, located at Lagrange point 1. And the BZ has solidly gone into positive territory here. So while the solar wind speed remains elevated at 537 kilometers per second, it's all about the magnetism. And remember, folks, March is the second most geomagnetic month. So only after September does March rank in terms of earthly geomagnetism. It all has to do with the collision of solar protons with Earth's magnetic moment. So, and thanks for leaving a comment, Chemebadeka. If I pronounce your name wrong, I apologize. Chemebadeka. Let's take a look at the LASCO coronagraph here and see if the coronal mass ejection is showing up yet. I think it's a little bit too early. And actually, let's go to the Integrated Space Weather Analysis Center and see what's showing up on the stereo A coronagraph. So if you're familiar with the Integrated Space Weather Analysis Center, this is what the homepage looks like. If you're not, that's even more important because, again, this is what it looks like. You can get to the stereo A coronagraph there on the 6th page of the solar tab. And the currently occurring coronal mass ejection, not likely to be earthly directed. It's very far off to the northwestern limb, and it's not showing up on the data yet. So that's really not going to do you very much good. You're not going to be able to see it. So if you just tuned in, this is what we're talking about. Got a huge solar prominence up there. Just splentacular imagery from the GO 16 SUVi. We love the wide field of view. So great at showing all of those details of solar prominences, coronal mass ejections, and so on. So we're seeing all kinds of features here not associated with grand solar minima, but associated with an active, normal sun. If you were banking on the sun shutting down, sorry, it's just not doing so. And there are your comments on the screen. Thanks for leaving comments. Let's look at some additional weather stuff here. We're going to head to, let's shift gears and check out windy.com. If you've never seen windy.com, there's a great mobile app associated with it as well. And we're not paid to say so. We just do, because it's the truth. So here's where we've got some heavy stuff happening. One of the things you could look at is the weather radar and satellite imagery. So there's the satellite imagery. Just give that a minute to load there. That's just the last 2 hours. And you can see some heavy weather here. There's going to be some continued issues throughout the day today with severe weather. Here's a weather radar. And allow me to mute the thunder sounds and animate this. So there you can see the most severe weather there around Memphis. It's going to brush just to the north of Nashville, it looks like. Bowling Green's in the crosshairs, Lexington's in the crosshairs, Cincinnati's in the crosshairs, and you're going to get training. So just to do a quick description of what training is, let me just bring up the Epic pen. Here at the Smash News Network, our pen is Epic. And just give me a moment here. I'm going to take about 2 more minutes. I'll be right back. I'm going to play you another track here from Golden Cat Productions. And we'll play you one that is available on the internet. This one is called Le Tour de Chance Speed. And don't take speed if you're in the Tour de France. That would be an illegal performance-enhancing substance, a performance-enhancing drug, a PID. Anyway, here's that track. We'll be back in about 2 minutes. And we've changed the playlist. We've decided to play Honey, I Shrunk Your Soul. right, and once again, thanks for leaving comments here, Jeannie and Chinmay Barheka. Jeannie asks, what do you think about the USAF saying they will have control of the weather by 2025? I would say that I don't see any proof of the United States Air Force suggesting that it's going to have control of the weather by 2025 or any time, because the U.S. Air Force is very pragmatic about what it attempts to forecast and what it attempts to do. It's aware of its capabilities in terms of weather modification, and that it's not capable of controlling the weather, just like everybody else who understands the physics. So that's what I have to say about that. Mankind is not currently capable of controlling the weather, at least not on a large scale, only on a tiny, tiny scale. So when it comes to things like weather modification, the facts are that there is some weather modification that's happening. Keep in mind what you're looking at here is a scale of hundreds of miles. And over scales of hundreds of miles, mankind's not capable of changing the weather patterns. So when it comes to tiny little aspects of the weather, such as hailstorms in Bulgaria, or maybe the jet stream over the Tibetan plateau, or small aspects of the weather like that, mankind has the ability to put some inputs there. So what I mean is, for example, over Bulgaria's been firing rockets at thunderstorms in order to divert hailstorms from destroying crops. That's a real thing. In Colorado, some people, occasionally, especially beginning in the beginning of the season, of the ski season, that is, there are people who have permits to go cloud seed to attempt to divert snowstorms onto their mountain and create conditions favorable for skiing and snowboarding. However, these are not what you would call large-scale attempts to control the climate or the weather, for that matter. And the suggestion that mankind is able to, on a large scale, control the weather is fully idiotic. It demonstrates a lack of understanding of physics and wattage and how much materials are required in order to drop a significant amount of seed in said cloud to cause a real difference. Also, if turbulence suddenly happens after you've cloud seeded, guess what? You've reduced the density of your cloud seeding significantly, that it doesn't work right. And it's been experimented with. It's a thing. Like weather modification is a thing, but the idea that we're going to be able to control the earthly weather patterns is just ridiculous. If we are going to attempt to control earthly weather patterns on a global scale, we would need to control the temperature of the Earth's oceans. So I don't know if you're aware of how much wattage it would require to heat up or cool down the Earth's oceans, but I'll just say it's a lot. So the same way it requires a lot of wattage for you to heat up the water in your aquarium or your pond or your swimming pool, it would require more wattage than that to heat up or cool down the Pacific Ocean. So I'll just leave that there and go back to windy.com's weather radar. And geez, there's some violent stuff happening here. It's just going to brush up against Memphis there. Memphis is just going to get the tail end. Jackson is going to get hit harder. Nashville is going to have some fireworks to its northwest. Lexington is going to get hit head on, and so will Louisville. In fact, Louisville's getting hit head on at the moment. So hopefully that helps a little bit. I mean, atmospheric physics are what they are, folks. There's a satellite imagery we've switched over. A lot of, shall we say, dark clouds over this portion of the country. Places like southern Indiana and Illinois. Most of Kentucky going to see some very cloudy skies. a couple little breakthrough spots down here in the southeast. So we've got another question here, and thanks for asking, Chinmay Bateka. What's your take on regions 2954, 2955? Do sunspot act and behave in a predictable pattern? That's a good question, and thanks for asking. They do behave in somewhat of a predictable pattern in that they occur throughout the 11-year solar cycles. Does that mean we can forecast things like how many flares they'll produce? To some degree we can, right? Because to the extent that sunspots have a magnetic complexity, where they have opposite polarity magnetic fields associated with them, when we have what's called a beta-class sunspot, that is a sunspot that's more magnetically complex than what we call an alpha-class sunspot. Those only have one magnetic field. Beta-class sunspots have both north and south pole associated with them. And what that does is that increases the likelihood of solar flare. So they are predictable a little bit. That's part of the reason why we make the videos, because there is predictive value. And you never know what you're going to figure out when you just start viewing things. In other words, if you immerse yourself in the data, you may receive answers to questions not asked. And that is largely what has happened at the Smash News Network, least busted name in news. We've explained the solar cycles and some other things associated with astrophysics and cosmology. So, this video here, this particular live stream, this is in the genre of news and politics, because advancements in science are indeed news, and politics do indeed relate, because people who are doing cutting-edge science, while we're attempting to Mensa, make Earth not suck again, we need funding. And so that's part of what is going on here at the Smash News Network, least busted name in news. And look, we noticed a lot of nonsense, tinfoil hat-wearing crap, and other garbage on the internet. And so it was time to do a deep dive into heliophysics. I realized in the mid-90s that there was a hole, maybe you'd like to say a black hole, in the realm of cosmology and astrophysics. And since the sun is the Rosetta Stone of cosmology and astrophysics, if there is a lack of understanding in terms of heliophysics, then there's a lack of understanding in terms of cosmology, because mankind's ideas of what's going on in the hearts of distant galaxies is a function of what mankind believes is going on in the heart of the closest star, Helios, El Sol, the sun, whatever you'd like to call it, the local yellow dwarf. It might be a little weirder than most people think. And frankly, we're hoping that it is. And that's part of the reason why we have a channel. So remember, folks, if you're not doing something that's on the cutting edge, all you're doing is rehashing a bunch of old stuff that other people already said. So if you're not pushing the boundaries, as far as a scientist, are you worthy of existing? That's the real question that you have to ask yourself. Are you simply trying to create additional confirmation bias in the realm of science? Or are you actually attempting to advance the science? So if you've never read our mission, you can find it just by typing in the URL. So if you head to smAsho.com, smAsho.com/forum/mission, you'll be able to read about our mission. And it is to assist, study, and report on the ongoing formation of a unified theory of physics. Because one of the problems that occurs with physics, folks, is when you measure things to a tighter and tighter margin of error, you get to the point where you have to ask yourself what it is you're measuring. Are you measuring the limitations of your own instrumentation? or are you measuring the actual physics that you're attempting to measure? Things that are moving at light speed are pretty tough to measure the speed of, measure the location of, and so on, because your equipment is operating at speeds below the speed of light. So I'll just let the mission scroll here. You can feel free to read it if you like. If you're viewing the channel, we prefer that you would have like a high school level of physics understanding. I know on YouTube there are a lot of channels that are paid millions of dollars a year to have like a third grade understanding of physics for some reason. But I've personally taken physics and continued to study it and read recent publications for decades. Now, a little background on me. I learned to read at age 3, so I didn't have to go to school. When my mom enrolled me in kindergarten, she said, well, you have to go to school or I'll go to jail. So there's that. But I started reading about things like cosmic rays in 1981. And that was when I was like 5 years old. And I realized that the universe is quite an interesting place. And it might be even weirder than you think. So that's sort of my background there, just to give you an idea as to how I got into the realm of space weather. I wasn't just a hack who was jumping on the bandwagon because space weather is popular on YouTube. That's not what was going on at all. So just to sort of clear up any confusion about where I came from. Space, by the way, is where I came from. So how about if we play one more track for you here? We're going to put your comments back on the screen in a moment. If you've got other comments to leave them now. We're going to play one more track here. This one's called Temple Strike. And this one is available only on this video at the moment. So bear with us another about 2 minutes, and we'll be back to close out the video. All right, so we've got another question here. I'll address this. Jeannie asks, during a large forest fire, could a thunderstorm without lightning be created to extinguish the fire? The answer is no, because there's no such thing as a thunderstorm without lightning. So, no. If you figure out a way to suck the air out of the area, then sure. But yeah, that's not a thing. So yeah, that's basically it, folks. I just wanted to cover the severe weather here. Let's put that back up on the screen here for a quick moment before we close things out. I'll go back to windy.com to bring that back up, as we've got some pretty harsh weather happening here in a decent portion of the country. So we'll just show the satellite. We'll zoom in a bit on this convergence zone. A little bit of cold air mixing in there and causing some violent equilibration of the atmosphere. So Kentucky, southern Indiana, southern Illinois, and moving into Ohio here is sort of where the weather is kicking off. There's the weather radar. And it looks like this system is just going to brush up against Nashville here. There's going to be a continued severe weather to the northwestern portion of Nashville. This system might just kind of brush across. It's moving a little bit to the east. It's going to largely miss Nashville here. So that'll be a great location to actually view the system from tall buildings. Yeah, I don't see a scale on the map here, but that is a significant distance there. If it's not too cloudy at Nashville, probably pretty cloudy at Nashville. Let's go back to the satellite for a quick moment. Not super cloudy there. So you may have a great view of a squall line right there at Nashville. Some clear sky looking like it's coming through. Large portions of Tennessee will get a great light show from this system. Jeannie, I would have to ask you how you define a thunderstorm without lightning. So how exactly does that work? If you have a thunderstorm going on overhead and it's got thunder, right? What's the definition of a thunderstorm? A storm producing thunder. Just because you don't see the lightning doesn't mean there's not lightning being produced by the storm. There could be thick clouds in between you and the lightning strikes, which would prevent you from being able to see it. Hence, there's no such thing as a thunderstorm without lightning. It's just not a thing. Now, I've seen thunderstorms where we've done the math and calculated that the storm is 18 miles away. So that's a thing. It could be behind a mountain. You could still be hearing the thunder from it. There's all kinds of different reasons to have a thunderstorm that has thunder but no visible lightning flashes. It doesn't mean there are no lightning flashes. Anyway, that's about it, folks. I just wanted to do a quick little live stream here about this, about the geomagnetic storm subsiding, the solar prominence. Oh my God. I wasn't going to talk about Gond at all, but now, oh my God, now I'm talking about Gond. Not to be confused with Gandhi. Anyway, we'll close out with some imagery of the closest star once again. Congratulations on realizing the channel exists. Make sure you press like and subscribe if you enjoy the content. And we'll talk to you soon here at the Smash News Network, least busted name.